Please put your name on this. We are in block 3 of day 1. All right. So our final unit, surface area and volume. And luckily, we've already started talking about this. So most of this should go relatively quickly.
Do we have 4 classes left?
We have 5 including today. So 3 this week, 2 next week. This.
Do you say 2 next week?
Yep.
We have more than 2 days next week.
Well, only 2 days of math. Right? So there's only 4 lessons in this. The third one, the last one, we'll see if we can get to it. But
1 plus 12.
we've done most of this already. So I started you guys off, I think like February, March. We started looking at areas, all right? And so it was like when we were practicing all those shapes and those equations. So that's what we're doing now, right? So let's go to the first page. And I'm going to remind you of the equations that we use, okay? And you guys got very good at writing these out. Okay, so we have this shape here. First off, this is called a square. And a square has all of its sides exactly the same size. This little line here means anything with the exact same symbol on it, it's the same size. Okay? And if I call this like length or width, they're all exactly the same. So the area of a square, so I'm going to go area, I'm going to draw a little square underneath it. Does anybody remember what it was? I'd be impressed if you guys remember this stuff.
A square.
No.
Ileana? Not pi. Pi was used somewhere else. Nolan?
Isn't it like a squared, z squared equals c squared?
No, that was the triangle. That's Pythagoras. Xavier? No, that was perimeter.
Width times length.
Oh, length times length. Or side times side. Or width times width. You just
Never done
multiplying those two together, huh?
I've never done that.
Yes, we did.
We never did length times length. We did
Yeah.
We did length times width.
Yeah. No. That one is when we use for the rectangle. So now, rectangle, Chloe, and a square are very similar, except for one of the sides are elongated. So here we have this side and this side are the same length. That's why they have the same symbol on it. We'll call this length. That's a length. That's a length. Now the other side is shorter. Right? So I'm going to use a different symbol. A double symbol means, hey, anything with a double hash mark are the same. So I'll put a W here. And this is the other formula you remember. Area of a rectangle this time was equal to length times width. Okay. Now, Ileana, you said the word pi. What shape had pi? Was it the square? It was a circle. So the circle one, you needed to know the distance from the middle to the edge. What is that distance from the middle to the edge called? Had a name. Started with the R.
radius.
Radius. So I'm going to put a little R here in the formula for this. So area of a circle was pi times R squared. And I said, hey, for pi, for purposes of grade 8, you can use the numbers 3.14 and R squared. You guys remember what we did for R squared there? What is R squared? Anything with exponent 2 just means multiply itself. So we just did R times R. So area of a circle is pi times R, or R squared. Either way, okay? So this is a little bit nicer to enter into your calculator. And the tricky one. Ooh. Okay. Area of a triangle. You guys remember that one? No?
Someone said it already.
Did they? For the triangle?
A squared plus b squared equals c squared.
No, that was to find your hypotenuse or your leg. That was not to find the area. That was Pythagoras, right? So. Ooh, yes.
Times length times width.
So, here, to know this, you need to know the distance across the bottom. We call this the base. You also needed to know the distance from the base going straight up to the peak.
Base times height.
And that was called the height.
You said length times width.
Yeah, it's okay. So the area of a triangle was a half times your base times your height. Okay. Now, sometimes a triangle doesn't look like this shape. Right? Sometimes we have a right angle triangle like this.
Wouldn't it be the same?
It'll be the same thing. This is your base. And your height is now your distance from your base to the peak. And that becomes your height. Right? Still the same meaning thing from the bottom to the opposite peak. Okay?
Except it's
Right?
not using
Now.
the
I like looking at it like this because it sort of connects up with what James was saying. Because if you, maybe I'll do it off to the side here. If you look at a rectangle and you cut it in half along the diagonal like this,
It becomes two right angle triangles.
it becomes two triangles. So the area of a triangle is just half of the rectangle, right? So you see how the formulas are interconnected, right?
Done all of these.
Yeah, we've done all these. So we're going to go quickly. So today, we're going to do a little bit of notes. We're going to do some assignment. We're going to come back and do some notes. And if you have time, we're going to finish off the assignment, okay? So let's put this quickly to work. We're going to bounce back and forth.
That
Okay.
does not make sense.
Yes. We have a square. Yes, Reed. After we're done our notes. I'm going to say this is 5 centimeters.
5 centimeters and 5 centimeters.
Okay, remember the process. First step, I want you to write out the equation. Area is equal to length times length, or side times side. First step, write out the equation. Second step, replace the letters with the value. So our length is 5. So next step, area is 5 times 5. Last step, calculation. Area is what number?
25 centimeters.
Now 25, not centimeters.
Centimeters squared.
Centimeters squared. Remember, area always has square units. So whatever the unit here, centimeters, we square it.
Because the area is the inside, correct?
Huh? The area is, yes, the amount of space the inside takes up. Okay. All right.
And the outside.
Next one. Area of a rectangle. So we start off with writing the equation. Length times width. Oops. I need to give you the information. Let's call this 12 centimeters. And let's call this 4 centimeters. Like this. Okay? So, step 1, write out the equation. Remember, you guys are not going to have to memorize these. I'll give you them on your test, or either on your test or right on the board. So I got these sitting here ready for your assignment. Step 2, replace the letters with the values. Area equals 4 times 12. Or 12 times 4, it doesn't matter if you mix those numbers up.
28 centimeters squared.
It is not 28 centimeters squared.
48, sorry.
48 centimeters squared. Thank you. Area
48 down.
equals 48 centimeters squared. I think you guys got the hang of this. Okay.
You forgot to add the squares.
No. I have the squares. It's a little messy. It's there. Okay. Circle. Let's call it. Oh, actually, let's change this up. let's go like this. And go from here to here, and I'm going to say that is 3 centimeters. It's a circle.
1.5.
Okay, good. So the equation for a circle, area of a circle, is 3.14 times r. Xavier saw it right away, what Mr. Dhaliwal tried to trick you with. I gave you the distance all the way across the circle, but the circle formula requires the radius halfway across. So that's only 1.5. So this number here is 1.5. So you go 3.14 times 1.5 times 1.5. Grab your calculator, see if you can do it. Make sure you try it, right?
Why do we need a calculator for this one?
You can do that in your head.
What is it?
7.065. I got this one.
What did you come up with this?
Casho?
I got 7.065.
3.5?
7.065. That sounds about right. Okay? So now, Casho calculated is 7.065. If I say, give me the answer to 1 decimal place, what would this be rounded to?
7.1.
7.1. So 1 decimal place is here. Remember, we look at the number after. 5 or bigger tells us to round up. So let's say this is 7.1 centimeters squared. Okay. Next one. Let's call this, let's see, 4 centimeters going this way. And let's call it 6 centimeters going this way. You do it. Step 1, write me the equation. Step 2, fill in the numbers. Step 3, calculate. Those 3 steps, right?
It's 12.
All right, that's what I've talked to my grade 9s about, right? I've been teaching this for a while. I can teach it clear enough. You can go, yeah, that makes sense. You nod your head as you go along. But when it comes time to do it yourself, if you haven't done the practice, that's when things kind of fall apart. All right. Okay, I think I'm going to do one more question with you, then I'll get you guys to start doing an assignment here. Okay, so we can have some sort of irregular shapes like this, where we did a little bit of this right at the end before we stopped talking about this in the springtime, right?
The answer is 66.
We don't have an equation for this shape. So what we do
But yes, we do.
is
Cut it.
we break that shape into shapes that we already know equations of. So if you look at this, right, you can break this up into rectangles and squares and stuff like that. Like, so I can, if I put a line here, I can have 2 rectangles, right? So I don't need the formula of this shape. I need just the formula of this shape and this shape. So you need to know.
Which one's the square though? Because it says.
Oh, it may not be a square. Square or rectangle, we'll see. So for this big box here,
It's a rectangle.
it's a rectangle, and we have the how big each side is. We know that this side. So we'll call this. How about we call this triangle or rectangle 1? So area of rectangle 1. We'll put a little 1 here. Is length times width, right? And we try to go, well, maybe I'll go off to the side here. More room there. Area of the rectangle is length times width. I have 11 times 12. Who remembers their 11 multiplications?
110, right?
No. 132.
132, yeah. 132 centimeters square. So we know how big this one is. We need to figure out how big this is. We'll call this number 2. Okay? So we need to know how big the sides are. So this length right
I
here.
think 10 yards and 5 yards.
How big is this length right there?
10 yards.
I have a vote for 10 yards. Do people agree with Xavier? Is that 10 yards?
You can't measure it, so.
Yes, you can.
You can base it off the other information you have on the table, on the diagram.
It's not 10 yards.
I hear a vote for 11.
It's 10.
That's
5.
wrong.
Okay.
5?
Oh, no, because if you cut the shape off.
Okay.
How do we know?
Let's look at this.
10 yards. Up is 5.
I just moved my arrow from up there to down there, so it's not in the way. We know that all the way across here is 21.
Look at the bottom though.
We know that all the way across the bottom up to this spot is 11. So how far do we need to go over here? Yes,
You can subtract 21 from 11 from 21.
21 from 11, you can subtract that, so we have another
Or you can just look at it.
11.
No, I can't.
Oh, sorry, 10,
I can't look at it.
right? Because 11 plus 10 is 21.
Or you just look at where the 10 is and just put it on top.
No, because that 10
It's for both.
is telling you it's this way.
That 10 is for both.
No, that 10 is saying up and down on that side. Okay?
10 both ways.
So, if this is 10 and this is 12,
The thing's 2 yards.
and this little gap there is 2 yards. So one of the things that you guys probably going to find frustrating about this chapter is things are not drawn to scale. All right? You'd go, oh, this thing looks way smaller than this, should be about the same. Yes, if I agree, if everything's done to scale drawings, but you have to base everything off numbers. It's not done to scale drawings,
I
okay?
don't like numbers.
Okay, so now we have our second shape. It's a rectangle, so the formula is length times width. There you go, 10 times 2, which is what number?
20.
20. Thank you.
That was 10 and 12.
So now, are we done?
No.
No.
What else do we need to do?
Add them together.
Add them together. We figured out each piece. All together. Area total is 132 plus 20. So that'll be 152 centimeters square.
Yeah.
Okay. Now, that is just one method to do this. Does somebody see a different method to get to the answer for this one?
Add them all together, then times it by 2. I'm
What?
kidding.
Okay.
I have nothing.
All right. So now you don't have to write down this method here, but another way of looking at this is, I'm going to erase all of this right here, is you could have found the area of this rectangle here. Then subtracted out that little spot, and that would leave you with this shape.
That would leave you with 21 plus 21 and 21.
Right, so instead of adding, we're taking away, right?
21 times 12 would give you 152.
Yeah, you're still end up the same answer, right? So now, it depends on which way your mind goes with these kind of questions, okay? All right, should we do this one here?
No, don't do it.
Let's not do it. Let's just like.
Let's talk about it.
Boo.
We don't have to do it.
I don't like talking.
Okay. All right. So, what two shapes do you see here?
Oval. No.
No?
Half circle.
So, we have a half circle here. All right? Here you go, Caleb. All right? So, we're going to have, you're going to find your area of your circle and divide it by 2 or multiply it by a half. Right? Then, what other shape do we have?
So it's basically 4 and
What shape is this down here?
Rectangle.
A square.
Square.
And
So this one, it says this is 16, then they tell you this from the circle here, that halfway to the edge is 8.
so it's
That's 8. That means this is 8.
16.
Altogether 16. So you have your half circle plus your area of your square. Okay, you put those together, right, you'll have your answer.
Or you can just make it one rectangle.
Okay, so we're going to stop. And I'll give you your assignment. This next section is what students typically find the most difficult. Some of you guys will find it easy. Others might find it difficult. Because we're looking at three-dimensional shapes. And sometimes students just have a hard time picturing three-dimensional shape on a piece of paper. So luckily, there's only like 3 or 4 shapes that you mainly do in grade 8. First one, this is called a rectangular prism. It's like a Phoenix box, right? So if you're asked to find the surface area of a 3D shape, you need to find the area of all the outside sides, right? So that is when you ask to find the surface area, is add the area of outside side. So here on this shape, first thing you need to be able to do is count how many outside sides are there. So if you have a box like this, how many sides are there? 6. Shh. Quiet, please. 1 on the top, 2 on the bottom, then 4 along the outside edge.
On the bottom.
Oh, sorry. 1, 2, then 4. All right. Okay. So we count the sides. Those sides are called faces. Okay? The face, the left face, right face, top face, all right? Next is we need to calculate the area of each face. And once you have how big each one is, we add them all up. And the word add means sum. Okay? So, to make life a little bit easier, you gotta realize that some of these sides or faces are identical. So you don't want to repeat the calculation over and over again. You just want to multiply by how many times that same side show up again. Okay? So,
multiplying it by twice.
let's go here. Let's start off with the top. And here's my suggestion to you, is shade it in. It helps. So here's my top. I'm going to shade this in. Okay? I'm going to shade it in. Then I'm going to draw it out. Okay? It's a rectangular shape like this. If it's a rectangle shape, I look at my formulas. I need to know the length and the width. So I need to know how big each side is. So off this diagram, how big are each side of the top there? Read. 6 and 17.5. So this distance here, you can see it's right same as this line here. It's 17.5. And the 6 is from here, this line here. It's the same as this line here. Okay. We'll call this, I don't know, side A. Why not? As the first one we're doing. Now, to make our life a little bit easier, we want to check the rest of the shape here at least. Does this shape get repeated anywhere?
Yes.
Where?
The bottom.
The very bottom. So this exact same shape is also down here. Does it get repeated anywhere else?
No.
No. So once we figure out how big this is, it happens twice. So we want to double it.
Doesn't it get replaced here, and these two sides too, because they're the same, still the same?
They're not the same. They're different sizes. We'll look at it. So here, let's do the calculation. Area is equal to length times width. 17.5 times 6. What do we get? 17.5 times 6. What number is that? Okay. Sorry? 105. Okay, so now. Shh. Yeah. After we're done our notes. There are 2 of these. So we need to double this. So that's the area just for the top. For the top and the bottom, we're going to times this by 2. So double that is 210 centimeters squared. Okay. So that's A done. Or A and the backing side. Okay. So we got 2 out of the 6 sides taken care of. Right? So we have another 4 more to go with. So I'm going to go with something that's easier for me to color in. I'm going to go for purple. I'm going to go for this side here. I'm going to draw it out. And I'll call this side B for just my labeling purposes. All right? Now, it looks square, rectangular-ish, so we need to know how big each line is. How big are the 2 lines for this triangle, or rectangle, or square, whatever it is? Are they the same? Are they different sizes? How big are they? Ileana? $11.2 and 6. So 6 along the bottom here, 11.2. Now, does this shape get repeated anywhere? Yes, Mallory, where else? On the other side. So way over here, it gets repeated. Over here as well. Okay. And so there are 2 of these. So we're going to find the area of it. Once we figure out the area, we'll double it. There's 2 of them. Okay. So we step 1, write out the equation. Area is length times width. You've done the hard part. You drew it out. You got the numbers. Now you just got to calculate. 6 times 11.2. Can somebody do that in their head? Is that possible? All right, 6 times 11 is 66. So what's 6 times 11.2? 67.2. Nicely done. 67.2. So that's just finding this side here. Now we got 2 of them, so we need to double it. Oops, double. Because we have 2 of them. What's 67.2 doubled? 134.4 centimeters squared. Okay. So we've got 2 done here, 2 done there, 4 sides altogether. We said there's 6 sides, so there's another 2 sides to go. So let's go blue. So I got this in the front. All right, I'm going to draw this blue rectangle here. All right. How big are the sides for this rectangle here? This is the hardest part, picking up the information. So looking at the front. Ileana? Yeah. So 17.5 here, and then we're looking for this side. Ileana's right. It's the same as this distance over here, which is 11.2. Okay, and we'll call this side C. And this gets repeated as well, because it's on the back as well. So there's 2 of these. So whatever we have, we're going to multiply by 2. So length times width, 11.2 times 17.5 What do we get? What number do you guys have? $196. Okay. I haven't done it, so I'll assume it's right. All right, and the units centimeter squared. Okay. So now, are we done? No, we've done all the sides. This was front and back, but are we done?
Add them all up.
We need to add them all up. We found all the sides.
You haven't done that side.
No, we doubled it. Oh, sorry, that's right. William's right. We need to double this. We need to double it. Oh, that's what you meant. Okay, we double it. We get 392. That's right, sorry. So then we need to add up all the sides. So surface area, that's S dot A. S for surface, A for area is all your sides added together. So you have your 210 plus your 134.4 plus your 392. You add all those numbers together. What do we get? We're almost done. 736.4 centimeters squared. Okay? And that's it. All right? So I don't think we have enough time.